Hello, my name's Ross Constable, and as part of my Test It, Trust It series, today I'm going to be talking about an adjustment that's made by many people to their PPE that could be putting their safety at risk. Today we're going to be talking about insoles in safety footwear, but just a little bit of housekeeping to begin with. So insoles, technically speaking, are an integral part of footwear and can't be removed, whereas we're going to be talking about insole socks or Insocks, which are an insert in safety footwear that can be removed. Insoles and Insocks are used interchangeably in the industry, but for the purposes of this, we're going to focus on the technical term, which is Insocks. Some workers prefer to swap out the Insocks of their safety footwear for reasons of comfort, but this can negatively impact on several protective qualities of the footwear itself. Impact and compression relies on a particular clearance underneath the toe cap, and swapping them out for thicker variants reduces this and makes it more likely for a serious incident to occur. However, the primary reason that you shouldn't be replacing your Insocks in safety footwear is the electrical resistance properties. Anti-static footwear is designed to reduce the build-up of static electricity. Static electricity in itself isn't a hazard, but it can be dangerous in certain types of situations or roles. The main aim of anti-static footwear is to reduce the risk of electrostatic discharge, which can ignite flammable materials, vapours, and even damage sensitive electrical equipment. Now, the energy and current involved in this type of discharge is very low, but the voltage can range between 1 and 20 kilovolts or even higher. Insocks used in anti-static footwear are designed and manufactured to have specific electrically conductive properties. This might be a case of anti-static stitching or resin, aluminium foil, or a combination of all three. It's rare, but you can also get fully conductive inserts. Insocks are essential components of anti-static footwear, and their importance cannot be ignored. If they're removed or replaced for whatever reason, then this can lead to electrostatic buildup. This creates problems in workplaces that use flammable materials, vapours, oils and gas, and even electronic equipment. If there's a need to replace the original Insocks, then the anti-static properties of the replacement should be considered, and you can buy conductive inserts that work with anti-static footwear. Once the Insocks have been replaced, it's highly recommended to test the footwear to make sure that they're compatible with the new inserts. This can be done through laboratory testing or by using a plate tester. Seeing as we're talking about anti-static footwear, please don't forget about basic maintenance of safety footwear, as this is often neglected. Contaminated soles make it more difficult for the electrical current to pass through. Permanently soiled soles, such as when the user steps in fresh paint, should be removed from use and new safety footwear issued. It's also important to remember that anti-static footwear and electrical hazard footwear are two different types of PPE. Their specifications vary widely and they shouldn't be confused. Anti-static footwear is not designed to protect a user from live electrical hazards. In summary, I guess a simple way to think about what I've said in this video is that PPE should be used as issued. Its original setup is how it was tested, and so this is how you can trust it. Any modifications of PPE could cause it to lose its protective properties, which could lead to injury or worse. These modifications should only be carried out with careful consideration to the risks. If you're unsure, please seek professional advice before carrying out the modification. I hope this has been useful in keeping you and your colleagues safe at work. Look out for my next video where we'll talk about the permeation of chemicals.